Okay, I wanted to do a little video on, okay, this is hierarchy of collection framework in Java, but I kind of, really wanted to demonstrate, the connection between interfaces and classes. Now, the arrows on this, I think, kind of are pointed the wrong direction, but you can look at it this way. So this right here, this iterable interface, it represents the fewest number of methods that it's required to be implemented by the classes ultimately. Okay, but you got this iterable, which is actually the smallest collection of methods. Let's see, iterator interface, it just implements basically these three methods here. So, however, the collections interface, will actually have to implement those three methods and it adds to it. So, and so apparently interfaces can kind of inherit from each other or whatever. I suppose is how you look at it. I don't see that there's any other way you could look at it, honestly. Um, yeah, the collection interface. I don't think they define the methods here, but it probably adds method. And remember, interfaces don't really deal with your member properties. They don't deal with class properties, just class methods, and they can though implement constants though. So you can have a bunch of like variable constants or whatever in there. Defined for like key values and things like that you may want to enumerate information into and so forth. I don't know if they support enumerations or not, but you can basically do that. I mean, I can set a bunch of like color red, color pink, color blue, that kind of thing. So it's just you can just plug that description into your function or whatever, and then it takes care of it. So I mean, that's the usefulness of it. Defining certain constants, that you can set things to, not just things like pi or whatever, or e, the natural logarithm number, but, but things like, flags that you may set your, various, you know, uh, methods to, or that you may actually end up setting some of your properties to in a class. But at any rate, the point is this has fewer methods, but it's, again, interfaces are mostly about methods. So, but this would be considered the interface with the fewest number of methods in it. But then this builds on that. This collection does. It includes these and adds some to it. And like this list, queue, and set, they include this and this, but add something to it themselves. But they split, so this will add different methods to this set, then this will add, and then this will add. So these will all have both of these incorporated in them, but they'll add their own specific methods that the other ones aren't aware of. But then, at any rate, once you get down here, for example, you have a class that implements these interfaces. So what you can do, and these classes here implement this interface set, and these classes here, implement this interface set, and this class is, actually a subclass or a parent class of the vector class. So, in other words, this vector is derived off of this class here, but then ultimately, this has to implement that interface. I guess at this higher level. If I'm reading this right, I mean, this may be backwards, given how they drew this. This may be a parent class and this is a derived class, but I kind of doubt that, because a stack, the vector you would think would be derived off a stack, not the other way around. But in any event, the point is that all these classes implement this set of interfaces, that's added here plus this plus this. So you can count on, like these classes all implementing all these methods here and all these methods here. But this class here only implements all these plus this set, but it does not implement these two sets. So that gives you an idea of the the kind of model. But these interfaces enforce the idea that these classes will implement these methods because you have to. You can't do it, but they can, of course, provide a stub method. In other words, they pay homage to the method they're supposed to have without actually doing anything in the function, or the method. But but again, because that does work, and then I've proven that in some of the program tests I did. But the point is you don't have to, but you can kind of consider on this level that they probably all implement most of the methods that are required by the interface. And here you have an interface too that further extends this whole set, and you can see that basically this is this is derived off of it by this class here. But this class here implements both this interface and this interface set. So this is an example of multiple inheritance, of the interfaces anyway. But again, multiple inheritance is really just you're not really inheriting anything, because these are just, they're like, .h files in C++, I mean, you're just declaring that the method exists and is defined in some C++ file, in a header file, for example, and that's kind of what these things are. They just kind of enforce the fact that you're going to have these methods defined in it, but they don't say anything about what the methods actually do. So there's no, like information, for them to be based on. And it's not even like it's overwriting anything, because there's just no code in the methods. The first, like this thing here, the very first, class that implements this set of methods, is this one here. Or this down here, this is one of the first class in this chain that implements this method. But again, this actually inherits this class, but then this class apparently is what implements this method stack. And it may be that this has to implement it too. I can't remember when it comes to interfaces, if it's got to be tied to your parent class or not, or if it can just be a child class that implements it. I think it can be just a child class. I don't see why you'd have to go down to the parent class. If you didn't want to. But in any event, that kind of gives you, sort of a confusing explanation about what, interfaces are in the class hierarchy and why they kind of use them. Because, like, if I wanted to use this class here, well, if I knew anything about this tree, I would know that it certainly implements these methods and certainly implements these methods, and with certainty implements these methods, and with certainty implements these methods. So if I'm familiar with all the methods in this class structure, I know I can count on it having at least this method set. And then the class itself will probably implement some of its own methods on top of that. So for example, if I was just learning all this, which I kind of am, this whole collection thing, and I was familiar with these two, well, at least that's a point of familiarity. I know that all these classes down here have this collection of interface functions. So if I was really familiar with these, I'd at least have some idea how to use some of the functionality of some of these classes here, because they all implement that common interface, and it'll have the same, it'll basically work the same. It'll accept the same inputs, to the methods, and produce a similar output in terms of its type. So, but again, it can specify the number of inputs and whether a function's overloaded or not, I assume. So it'll tell you how the function will basically work. Again, just like in a header file in C, C++. But it doesn't specify the exact code. So, but at any rate, that's basically kind of how it works, and some of the kind of advantage of it. It helps you kind of understand and have a certain commonality between a bunch of diverse classes. So, but it gives you some idea of, basically common functionality. So if you're, again, if you have a class that implements this interface, you also know it implements this interface, and then more specifically, you'll have to find out about this interface if you're not already familiar with it. And then on top of that, you'll eventually have to figure out what special methods the class may have that aren't in these interfaces. So that's kind of how it works. Damn it.